Multiplying mixed numbers by mixed numbers looks a little different when using an area model. Let's take a look. Go ahead and put a heading on your paper, multiplying mixed numbers. All right, and also jot down this problem. 1 2/3 times 1 1/2. Okay, so we've spent a lot of time using area models, and I want to use area model again for this, but something I want to point out is that I have mixed numbers now. So how will my area model look? Because previously, when I would multiply a fraction by a fraction, I would use a rectangular array, or just an area model rather, a square, and I would multiply that fractional piece. So this would be 1 linear unit, and this would be 1 linear unit, right? So we would look at these as being a 1 by 1 piece, and we're multiplying the fractional values. This is going to look a little different. Before we would begin with the model, I would like to look at these two mixed numbers, and I'd like to consider them what they would be like as mixed numbers as a fraction. So that would be improper because they're greater than 1. So with 1 2/3, what is my mixed number? So if you look here, what would make one whole? That would be 3/3. So I already have a whole. So I technically have 3/3 and then 2 more thirds, which would be 5/3, right? Hopefully that makes sense. Go ahead and write that. Now my next fraction, 1 1/2, okay, 1 whole would be 2 seconds, or 2/2. So I have one of those. So 2/2 plus 1/2 is 3/2, or 3/2 is how you would read it. Now, previously we learned that a procedure, remember this is just procedure, we can multiply numerators by denominators to get our new fraction. So let's do that just to check our work, because this procedure is pretty simple. Okay, so 5 times 3 we know is 15, and 3 times 2 we know is 6, right? Now let's turn 15/6 into a mixed number. So what makes one whole? That would be 6 6, right? How many of those can I make? Hopefully you're going to say 2. Okay, 2. Okay, and then how much is left over? 3 6, or 2 1/2. Make sure you write down 2 1/2 as well. Okay, so going back to this model, I have my 1 by 1, but we already discussed and we talked about this. This is greater than 1. So what I'm going to do is I'm going to make a 2 by 2 piece, and here's why. Because when we go to break these up, I'm going to be able to see the fractional pieces for what they are, and I'll show you exactly what I mean. So let's go to the first fraction. We have 1 2/3, and then we have 1 1/2. We have to pick where we want to place these on our area model. So I'm going to go ahead and place mine here. I have 1 2/3. Doesn't matter which side we put them on, right? Because of commutative property of multiplication. We have 1 1/2, okay? So looking here, just like our previous problems when we were just multiplying fractions, I'm going to be breaking up each one of these into how many pieces? Let's look at that denominator, okay? Thirds. We're going to break these up into thirds. So watch as I do that here. So just like before, I'm going to break these up into thirds. So look, see, I have this whole piece is broken up into thirds, and now this whole piece is going to get broken up into thirds. Okay, now we're going to do the same thing here. How am I going to break these pieces up? So there's 1, 2. I'm going to break it in half. And then I'm going to break it in half again. Okay? Okay, so just like before, I'm going to look at this fraction. I'm going to say, okay, I have 1 2/3. So I'm going to shade 1 because I have 1 whole. And then how many thirds? You got it. 1, 2. Right? Let's do the same thing for this one. Why don't you pause and you do the shading here, and we'll see if we did the same thing. Okay, did you shade 1 and 1 of the 2? So 1 1/2, right? Now let's close this off, okay? What we want to do here is we want to figure out how much we have here. So what is the value of this? So how many pieces is this? So let's go ahead and count that. We have 1, 2, 3 by 1, 2, 3, 4, 5. 5 by 3 would give us 15. Okay, now here's the part where it's really important you pay attention. What makes 1 unit? So what is our fraction going to be out of? A 1 by 1. This is why I put these little ones here. So I'm going to go ahead right now. I'm going to go over with a different color so you can kind of see this. A 1 by 1 is how many pieces? So if I were to say what makes 1 whole here, you would tell me 6/6, right? Because there's 1, 2, 3, 4, 5, 6 pieces out of 6 total would be 1 whole, okay? And that's where we get the 1 by 1, okay? Now, I already know that I have 15 total pieces, so I need to know 15 out of how many? The answer is not going to be out of the whole entire piece. It's going to be 15 out of what makes 1 whole. Now, hopefully you said, oh, okay, 15/6, right? Because 6/6 makes a whole. Now, that's pretty cool, isn't it? Okay, maybe you're not thinking it's cool. You might be thinking, wow, that took a long time just to solve this problem. I'd rather use the procedure. Well, the thing is the procedure is great, but we want to understand why the procedure works and what the procedure really means. So that's why the model is really important. Okay, the last thing I want to point out, just to make sure we're all in understanding, is how we were able to use the model to match what the procedure looks like, right? So first we took a look at these mixed numbers and said, okay, what does this mixed number really look like as an improper fraction to kind of help us see that, okay? Then we went ahead and used that procedure of multiplying numerators and denominators, and we ended up with the same exact improper fraction, right? Now this is the part I want to cross-reference. We said 15/6 equals 2 3/6 or 2.5. Now, knowing that 6/6 makes 1 whole, let's see how many left there are. So there's 1, 2, 3, 4, 5, 6. So that would be another whole. Okay, so we have 2 wholes. And then what's left over is 1, 2, 3, right? So 3 out of 6. And that's how we got 2.5. Okay, hopefully that makes sense.